In this lesson, we'll look at some of the special types of IPv6 addresses we can use and then review the different methods of assigning them. Just like IPv4, IPv6 has some special address types. Let's start by talking about link local addresses. Link local addresses are only valid on the current subnet and can be used for communication between two hosts when no other type of IPv6 address is set. But it's important to note that routers don't forward link local addresses. This is similar to an IPv4 APIPA address, but with IPv4, an APIPA address is only used when no other IP addresses are presently configured. With IPv6, a link local address can be used alongside other IPv6 addresses. In fact, when you use IPv6, your interface card is always assigned at least one link local address. Link local addresses are also used for automatic address configuration and neighbor discovery, which we'll talk about in a bit. Link local addresses always have to start with a hex value of FE. Also, the 10th bit from left to right always has to be a 0. This means that link local addresses can start with FE8, FE9, FEA, or FEB. For example, a link local IPv6 address using FE8 would look like this and be annotated as FE80/10. When a link local address uses FE9, the first 12 bits are used as shown here. But notice that the 10th bit is still a 0. FEA and FEB are very similar, with the 10th bit still being 0. Next, we have unique local addresses. These are private addresses similar to private IPv4 addresses and are used for communication with a site or between a limited number of sites. We see unique local addressing used for network communications that don't cross a public network such as the internet. Unique local addresses have an FC00/7 prefix and include addresses beginning with FC or FD. Following the prefix, the next 40 bits are used for the global ID. The global ID is generated randomly, creating a high probability of uniqueness across the entire internet. One of the most common types of IPv6 addresses is the global unicast address. As the name implies, these are globally unique with the global routing prefix assigned by an Internet Service Provider, or ISP. The prefix is typically 48 bits long. Global unicast addresses are similar to IPv4 public addresses and are used when systems send packets over the Internet. These addresses have a prefix of 2000/3. And all subnet addresses within the same organization have to begin with the same global routing prefix. They're uniquely identified using a different value in the subnet field. Next, we have multicast addresses. Like IPv4, IPv6 also uses multicast addresses to represent a dynamic group of hosts. Packets sent to a multicast address are sent to all interfaces with that specific address. By using a different multicast address for different functions, only the devices that need to participate in a particular function respond to the multicast. Devices that have no need to participate in the function ignore the multicast. Know that all multicast addresses use a FF00/8 prefix, and ones that are restricted to the local network have an FF02/16 prefix. This means that multicast packets starting with an FF02 aren't forwarded by routers. For example, FF02::1 identifies all nodes on the local network. This is the equivalent of the IPv4 subnet broadcast address, except there are no broadcast addresses in IPv6. Multicast addresses are used instead. FF02::2 identifies all routers on the local network, and FF02::1:2 identifies all DHCP servers or DHCP relay agents on the local network. Next, we have Anycast addresses. An Anycast address is a unicast address that's assigned to multiple devices. Packets sent to an Anycast address are routed to the nearest interface. One example of Anycast being used is with root DNS servers, where it's possible to have multiple copies of these servers spread out across the globe and DNS requests routed to the nearest root server. One final special address type is loopback address. IPv6 uses local loopback addresses much like IPv4, meaning that whenever a packet is sent to the loopback IP address, the TCP/IP protocol stack loops the packets back on the same interface without even leaving the interface itself. A local loopback address on a host is comprised of all zeros with a 1 at the end. Since this is such a long number and has all preceding zeros, it can be simplified like this. A local loopback address isn't assigned to an interface and is typically used for testing purposes, like for communications between services running on the same host. Okay, now let's look at the methods we have for assigning an IPv6 address. Using static full assignment, the entire 128-bit IPv6 address and all other configuration information is statically assigned to the host, just like we would statically assign an IPv4 address. This means you're responsible for manually configuring all aspects of the IP configuration for each device, and once assigned, the address won't change. You can also use static partial assignment where the prefix is statically assigned, but the interface ID uses the modified EUI64 format derived from the MAC address. Aside from static assignments, you can use an upgraded version of DHCP called DHCP-V6 to automatically configure the IP information. DHCP-V6 has two methods. The first is stateful autoconfiguration. This is when the entire IPv6 address is assigned using DHCP, just like you would use DHCP in an IPv4 network. You can also make use of stateless address autoconfiguration, or SLAAC, to get your IP information. Let's look at this process. The first thing a device does when it connects to a network is generate a link local IPv6 address using the FE80/10 prefix and then modify its MAC address to get the interface ID. The device needs to then ensure that no other devices have the same address. It does this using duplicate address detection, or DAD. This works by sending a neighbor solicitation to a multicast address to see if the address is already in use. If any other devices do happen to have the same address, they'll respond with a neighbor advertisement message, and your host will need to be configured manually. If no other devices respond with the same address, the process continues. Then the device sends a router solicitation message addressed to all routers on the subnet using the multicast address FF02::2. The router responds back with the global unicast address prefix, and the host combines this with its interface ID to generate its IPv6 address. Every network is different, and it's up to the network administrator to determine the best method for IPv6 assignment. You need to be familiar with each method and understand how they can best be used for your network. That's it for this lesson. In this lesson, we discussed some of the IPv6 address types, including the different unicast addresses as well as the multicast, Anycast, and loopback address types. Then we looked at the different methods for assigning IPv6 configurations, including static full, static partial, stateful autoconfigurations, and stateless address autoconfiguration.